Hello, thank you for choosing this video on highlights of what is new in Visual System Simulator version 15.0. In past versions of VSS, NL_F would be needed to read in AM to AM and AM to PM data, while AMP_F would be needed for frequency dependent data. In version 15.0, AMP_F has replaced NL_F. AMP-F can now read in several different data formats. Looking at the left side of the screen, we can see that 3 columns of data representing the AM to AM and AM to PM of an amplifier, while on the right side of the screen, we can see 4 columns encapsulating the frequency dependency of an amplifier. In short, AMP-F can reference either format inclusive of several other formats. In version 15.0, all file-based models inclusive of MDIF format can now interpolate and extrapolate in between data sets. For example, if the sweat variable temperature comes across 50 degrees, the model will interpolate in between the data set at the given temperatures to predict the outcome at 50 degrees. As a consequence of interpolation and extrapolation functionality, 2 new parameters have been added to all file-based models. So it's important to keep in mind these parameters and enable them when necessary. We now have a block in VSS that in effect allows users to analyze the impact of several digital pre-distortion algorithms on overall performance of a power amplifier. Let's take a look at an installed example test bench in VSS. If we look at the system diagram from left to right, you'll see a signal source. On the upper link, we just have the amplifier. And the lower link, we have our new DPD model that allows us to select from a pull-down menu several types of algorithms. And in the bottom of the screen here, we can see the signal before amplification, the signal with amplification, the signal with digital pre-distortion algorithm and amplification. And evidently, we can see that there's a significant reduction in ACPR via the use of the digital pre-distortion algorithm preceding the amplifier. We're excited to announce, in actuality, the models that we're speaking about here were released in version 14.04. The models are characterized by analog devices, and these models now reside in the VSS element browser under parts by vendor in the XML folder. An option to account for thermal noise on phase noise is now available in 15.0. What this amounts to is that you will now get the same results for overall phase noise mask measurement in time domain as in RF budget measurement. You'll now see in the RFB phase noise measurement settings that a new display parameter has been added to accommodate for the impact of thermal noise. Under Options, Default System Options, the RF tab, we added a new setting to use thermal noise as the noise floor. As clearly shown here, in the previous versions of VSS, one can measure a noise floor out of a filter that is significantly lower, in this case, minus 174 dBm hertz, due to the filter's response outside the band of interest. In 15.0, the noise floor is leveled at minus 174 dBm hertz. A new generic analog to digital converter has been added to VSS. In effect, the new block allows one to look at quantized analog waveform that is properly scaled relative to the number of bits, and of course the digital output values can be monitored as well. In previous version, it required several steps, inclusive of 2 models, to achieve what this new A to D converter does with 1 model or 1 block. And the name of the new model or block is ADC2. We've added a 5G new radio library built per Physical 1 specification, along with several test benches. The test benches for transmit and receive measurements for specific test models exist. Let's look at one of these test benches. The test bench that I'm about to open does come with the product. It comes with the evaluation product as well as the purchased product. Here, if we run this simulation, we'll look at the signal in the lower left-hand corner before and after amplification. In the upper right-hand corner, we'll look at an IQ plot of a reference measured IQ and the reference IQ plot, I should say, and the measured IQ plot. In the lower right-hand corner, we can monitor error vector magnitude as we sweep the input power. A test bench can be configured by choosing the appropriate test model per specification. As in this case, we're using a test model 3.1. That's the model used for error vector magnitude measurements. We can swap to another model to generate the corresponding signal for ACPR or ACLR measurement. We've added several RF improvements to the product. I'll highlight two of the improvements, or additions, I should say, through example. And let's go into the AWR design environment one more time and open up two examples. And specifically, we'll be talking about the new measurement called cascaded damage. The cascaded damage measurement can be found under RF budget analysis, C_damage. In effect, one adds attributes to specific components. We have two amplifiers here. The attribute added to the two devices was input power, 8 dBm. And in the event that the input power is exceeded on a device, it'll be highlighted in the system diagram as such. The blue trace is the measurement, and in this case, the second amplifier's maximum power exceeds 8 dBm by 1.25. The next example that we'll look at is the filter bank project. This project, or the system diagram, highlights the use of this new switch. In effect, this new switch can be configured to track the incoming frequency. In this instance, we'll be sweeping the input frequency four values here. As we sweep this input frequency, this switch will direct the signal to the according filter per frequency. So in this case, if we look at the graph here, we have a blue trace. That's the overall response of all the filters. The red trace here is the first filter. The green trace is the second filter, and so forth and so on. If you want to learn more about what is new in VSS, again, this is just a short video highlighting what's new in VSS. I suggest that you go here to Help, What's New, Visual System Simulator, and then you'll see some further descriptions of the features that have been added. We've added some more modeling capability when it comes to amplifiers. We've added new functionality to our phased array file-based model. Once again, thank you, and I do hope that you found this video useful in learning what is new in VSS version 15.0.